Today we're going to talk about barometric dampers. These are often found on boilers or gas-fired equipment that either have stacks over 30 feet or are atmospherically fired. The point of a barometric damper is to give a boiler a constant pressure or negative pressure or draft at the outlet of a boiler. The draft on a boiler without a barometric damper would be completely determined by the height of the stack, the temperature outside, and the firing rate of the boiler. And because all those things vary, a barometric damper gives us a tool to help make those more constant. For example, if we close this barometric damper completely, we'll see a very high draft reading on this piece of equipment. A draft reading this significant could result in excess air going through the burner. It could cause pilot problems and other issues. So by adding a barometric damper, we allow air to actually bypass the piece of equipment, dilute the stack, and reduce the amount of draft or pull on the boiler. But just putting on a barometric damper isn't enough, because putting this on gives us a relatively random pressure on the unit. So what I'm going to demonstrate is how adding weights properly to the barometric damper assembly can establish whatever outlet pressure or draft we desire. So we can start off with just a very little amount of weight, and we'll see a resulting increase in draft. Where we want our draft to end up being is actually determined by the type of equipment we have, the type of burner, etc. If you're in doubt, you can look at either the startup documentation from the factory for the burner or just the installation and startup manual for the piece of equipment. A typical outlet draft pressure that we may want to maintain would be a draft of 0.1 inches on the outlet. And basically that amount of draft at the outlet is going to ensure that I don't have back pressure generated by the stack and that I don't have a large amount of draft generated by the stack. So it really gives us a neutral stack that we are firing into. Now we've got a draft that's almost 1/10 of an inch. And what we'll see is that even if we vary the airflow through our draft system, we'll maintain that same draft or very close to it. I can simulate a change in the firing condition or the barometric conditions by blocking the outlet of the fan. And what we'll see is the barometric damper is going to move, but it's going to maintain approximately the same draft on the piece of equipment. And then when the situation reverts, it's still going to have that stable stack condition. So if you walk in your boiler room and the weights from your barometric damper are all lying on top of the unit, there's a good chance that you're not getting the appropriate draft for the piece of equipment. You could have sooting as a result, or just a lack of efficiency, or reduction in reliability.
Appreciate Jude stopping by with us and talking a little bit about draft control. Always great to get our Boiler University instructors involved and teaching us a little bit more about what we can be doing in our boiler room. Now make sure you like us on Facebook and follow us on Twitter and subscribe to our YouTube channel. If you don't mind, maybe just share a video. We'll see you next time on The Boiling Point.